Hello Algebros, now we're going to check to see if we have equivalent functions using either a table, a graph, an equation, a story problem, or a mix of any of those. So I'm going to do problems 3, 5, and 6 on the video, and 1, 2, and 4 will be your homework. So I'm hoping that 3, 5, and 6 give a good spread over what 1, 2, and 4 will be like. Alright, so number 3, looks like I have a quadratic equation. I know it's quadratic because of the x squared term. My graph looks quadratic, but that's not quite enough information to know if we have equivalent, if my equation represents my graph, and if my graph represents my equation. So what I'm going to do is I'm going to create a table of values. So I have my x input, and I'm going to be substituting the x into the equation to get my y value. And to make my life a little bit easier, I'm going to see what x values they have points on and use that. So let's see, I have an x value of 0, I'll use that. An x value of 1, I'll use that. 2, and then we'll do 4 values just to make it, alright. So we'll use an x value of 0, 1, 2, and 3. So I'm using 0 because it's definitely the easiest to simplify. So multiplying by 0 is just 0, leaving us with 1. Substitute my 1 in. 1 squared minus 7 times 1 plus 1. 1 squared is 1. 7 times 1 is 7. 1 minus 7 would be negative 6, plus 1, which would be negative 5. Substitute my 2 in. 2 squared minus 7 times 2 plus 1. 2 squared would be 4. 7 times 2 is 14. 4 minus 14 would be negative 10, plus 1 would be negative 9. And let's check 3. So 3 squared would be 9. 7 times 3 would be 21. Negative 21 plus 1 would be negative 20. 9 minus 20 would be negative 11. So we can see at x we have positive 1, and we look at our scale is going by 2, 4, 6, 8. So halfway between that would be 1. At positive 1, we should be down to negative 5, so 2, 4, and then negative 5. Looks good so far. Let's check a couple more just to make sure. Let's take 2, and it should be at negative 9. 2, 4, 6, 8, negative 9. And the last one for good measure, 3, should be at negative 11. 2, 4, 6, 8, 10, and 11. So yes, this equation is equivalent to this graph. So they are equivalent. All right, number 4 will be your homework. You'll do the same thing. Number 5, we have an equation and an input and output table. So this input and output table that we've been given is just like what I created in our last problem. So our input is going to be the x values, and our output will be the y values. So let's just test them to make sure that we get the output. So this is not fully simplified. I'm going to go ahead and fully simplify it because it will be easier with the input and output values. So if I fully simplify it, I have 3x plus 3. And so now I'm just going to test these values. So I have f of 1 equals 3 times 1 plus 3. 3 times 1 would be 3 plus 3 would be 6. Oh, right away. That does not line up. And if we try the next output, or the next input, we have 3 times 2 would be 6, plus 3 would be 9, and you can see that that does not line up. So these are not equivalent. Right? And one more example. Number 6, it says Alton is selling a few handmade toys at a community sale. After the first hour, Alton earns $5. After the second hour, he earns $10. And after the third hour, he earns $15. So our time is going to be the X, and the money would be the Y. Okay, so we have first hour, second hour, third hour, and he earned $5, $10, and $15, and let's check it out. So after the first hour, he earned $5. So far, so good. Second hour, he earned $10. So far, so good. And let's test. Third hour, he earned $15. And at 0 hours, he had $0. So yes, this story problem and this graph line up perfectly, so they would be representatives of equivalent functions or equations. Alright, so for your homework you will be doing questions 1, 2, and 4, the ones that I did not do, and you are testing to see if you have two equivalent equations or functions together. Alright, happy mathing!